g is a function such that g of negative x is equal to g of x. What is this telling us about the function?
It's secret. It's like,
What does this even mean?
that is not value. Maybe.
Could be, but not necessarily. Because we're going to have to figure out, if we know that this is true, what is, if we have g prime as the opposite of a,
Oh, the
we need to
value's
know
the same.
what is that going to be equal to?
It's in the same value that. Oh wait, there would be. It's the same value.
Are you sure?
Would it just be g prime of a?
Why? I can't hear you. You're going to have to speak up.
I'll let someone else answer. We'll get it right. I'll play most of it. Okay, Ms. Coble, would it be g prime of a because? What?
Why do you think it's g prime of a?
Because anything, like all the answers of g negative x and g of x will always be the same, so shouldn't their derivatives be the same?
I don't know. What is this telling us about the function? Something important here.
It's that the negative
Say that, Justin.
The even function.
An even function. So what do we know about an even function?
The derivative is the same on both sides.
Did you ever learn that about an even function?
Did you
What do you know, Curtis, about what an even function is, Curtis?
What?
We don't need your little sweet comments unless they're apropos of what we're talking about.
They kind of
Ooh.
It was it's a function that lies above, the values lie above the y axis, x axis.
Do they have to?
they do not.
They don't have to. What are some characteristics of an even function? Don't even think calculus. What are some characteristics of an even function?
It's even. Its numbers
It
are
doesn't have a negative sign.
No, it comes to whatever comes out will be an even number.
What do we know about the graphs of an even function?
They're above the x-axis.
What did you just say?
I said the graphs of an even function are above the x-axis.
Above the x-axis.
It's just gonna end on the same like side. It started going this way. It's gonna go that way. At the end, but if it starts this way, it's gonna go this way.
What? Give me an example, Adam, of an even function. Thank you, Adam.
That part.
She said Adam.
Is that an even function? Is x squared an even function? Okay.
Oh.
You said no. All right. Is that the graph of x squared? F of x equals x squared. What do you see about that function?
Value at any point is equal to the value of the negative absolute value of that.
Well, anything,
All values are positive.
anything,
Curtis?
yeah, all values are.
It reflects itself on the opposite side of the y axis.
Okay, so it is symmetrical to the
Across the
y-axis,
y-axis.
right? All right. This is an even function. If it's symmetrical to the y-axis, and we know that g prime of a exists,
Derivatives can be opposite.
I told you, Curtis.
all right.
Every
What?
Which several of you got that right, and I don't know if you just copied or calc checked that in somewhere. You need to know why it's the opposite. What if I told you that g of negative x is equal to the opposite of g of x? What would we know? What kind of function is this?
Odd.
Odd function. What do we know about an odd function?
X axis.
No, to what?
To the origin. It's symmetrical to the origin. question.
Just get out.
So they had the same derivatives. I only say this every time.
So their derivatives
What's that?
would be the same.
Will they?
Would they?
Yes, it will.
Yes.
Yeah, because if we had a point here, the derivatives here, negative A, if this were truly symmetrical, we'd have the same derivatives. All right, so you need to understand the difference between an even function and an odd function, and that's exactly what this problem was trying to get you to talk about. So when we're talking about even and odd functions in calculus, sometimes there's some simpler ways to calculate than having to find the antiderivative of the given limits. If you have an even function, and you are going to integrate it from negative A to positive A, and f of x is even, you can double from 0 to A of f of x dx. Much simpler if we just double that from 0 to A. So anytime you can plug in 0 for x values, it's so easy.
How can you just look at something and see if it's an even function?
How can you, Curtis?
Well, if it's, how could you,
Exactly.
Joey?
I mean, you just had.
How could you, Joey?
Yeah, Joe.
You asked Kurt first.
I'm asking you now.
Oh. Bert.
Well. If it's a 1, 3, 5, 7, 9, etc., it's odd.
No, it's not.
Then it's not.
Joey, it doesn't matter if it's odd number.
Representing it, and then it's even.
You just have to think about the graph, but like, if you don't know what it looks like, just plug in.
Okay, if you don't know what it looks like, how can you tell if it's an even function?
Well, I would say calculator, but you can
No.
think that way.
Yeah. Sure.
So, then all you have to do
So with
is
this
X
derivative,
values.
right?
Plug in like a 1 and a negative 1 and see
Something
where
weird
it's
is
derivative.
Oh. If the degrees of the deal are.
Is that an even function?
It's
How do you know it's even?
because
All I know
the exponents are
All of the exponents are even. So it's an even function. With our trig functions, do we have any even functions?
Sine squared x.
No, that's
No, cosine squared.
cosine squared x is not.
Cosine x is an even function
Is it flex?
because it is symmetrical to the
Right, correct.
y-axis.
That's sine.
Sign is
If
anything.
you have only odd exponents,
Or what if you have a mixture?
mixture.
What about an even and an odd?
then it's neither.
It's nothing.
This is odd, but if we added a +1, it would no longer be odd.
Am I?
That +1 moves it up around,
What if one of those was x?
and this is symmetrical to the origin. If you do a +1, then that moves it up and it's no longer symmetrical.
What if you have x squared is x?
It's even. All right?
Well,
So, if you're looking at the graph, it's easy to see if it's even. And you can calculate an even function this way. With an odd function, the integral from negative a to a of f of x dx, what do you think that's going to be? What does an odd function look like? Sam?
Flex on the origin.
All right, symmetrical to the origin. So if I'm going from negative a to a, and let's just, but the simplest odd function we know would be a linear. That's odd. All right. So we're going from negative a to a. What is that integral going to be? Think about when we first started looking at this and we used geometric It's
Zero.
an integral.
0.
Oh.
Cancel each other.
They cancel each other. So if you have an odd function and it's going from negative a to a, the integral is 0. But it has to be opposites here. In order for this to work, you